Good evening everyone, good evening. I welcome you all again to the NEET Elite. Hope you guys are doing great, having the good time. Well people, if I'm audible and visible to everyone, do let me know in the chat box with the thumbs ups. If I'm audible and visible to everyone, let me know in the chat box with the thumbs ups. Let me know in the chat box if I'm audible and visible to everyone. Good evening, Gayatri. Good evening. Hi, Arzu. Hello, Saurav. Hi, Joshua. Hello, Hadi. Well, Priya is giving me the green signal that I'm audible and visible. Is that? Of course, Saurav. I just love Vedantu. Yes. Perfect, guys. Perfect. So, I welcome you all again to the NEET Elite. As you all must be knowing, in the last session, it was our first session of the chemical bonding, and in the last session, we talked about the formation of the ionic bond. We talked about the characteristics of ionic compounds, right? We talked about lattice energy, hydration energy, everything was discussed in detail. I mean, the basic terminologies which were to be involved in this chapter, chemical bonding, yeah? So people, in the today's session, we are going to talk about one of the important theories in chemical bonding, which is what we call as Valence Bond Theory, right? Ganesh, I'm doing wonderful. How are you? Good evening, Fatima. Yes, Abdul Aziz, that will be also done. Hi, Karthik. Good evening. Welcome, guys. Welcome to the session. So before starting the session, let me introduce myself. For the ones who do not know me, my name is Wassim and I'm your chemistry master teacher right here. All right, guys. So before starting the session, you can just let me know how many of you wrote the Vedantu online talent examination till now. Till now, 3 attempts have been done for the vote. You can just let me know how many of you actually wrote it. Let me know in the chat box. Let me know in the chat box. I'm doing wonderful, guys. Well, Afshan has written it. Good evening, Fiza. Good evening. Let me know, guys, how many of you wrote the Vedantu online talent examination. 3 attempts have been done till now. Now there is only 1 attempt left, which is going to be held on 18th of April. So people, do register for that. It's going to be beneficial for you. You're going to get a lot of scholarships in this. Yeah. You are going to get a lot of surprises, a lot of gifts you guys are going to get if you are qualifying this Vedantu online talent examination. And at the same time, if you want to be the CEO of Vedantu for a day, you can just write it, qualify it, be the CEO of Vedantu for a day, right? Perfect, guys. Perfect. So, as I told you, the last attempt is going to be on 18th April, right? So, do not forget to register for this one as well, correct? All right, guys. And for the ones who have not liked the video yet, please do like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions, correct? Well, someone is saying it's buffering. Guys, am I audible and visible to everyone properly? Am I audible and visible to everyone properly? Can you just give me the green signal so that I can start the session? Yeah? Perfect, guys, perfect. So let me know in the chat box if you guys are super duper excited for the session. This is going to be the actual session of the chemical bonding, our actual first session. As you know, in the last session, I talked about the basic terminologies like ionization enthalpy. We talked about lattice energy. We talked about electron affinity, electronegativity. That's all basics from the chapter periodic classification basically, right? So this is the actual first session from the chapter chemical bonding, correct? Perfect, guys. Perfect. So let's get started with something called as Valence Bond Theory. Well, people, the first thing, what does this Valence Bond Theory explain us? Let me tell you the first thing which I would like to discuss with you. Let me tell you that it explains the formation of the covalent bond. With the help of this Valence Bond Theory, you'll get to know how a covalent bond is formed in a molecule, right? And that's something which we have to deal in the today's session in detail. So the first point which I want you guys to take a note of, it explains the formation of the covalent bond. Which explains the formation of covalent bond? This Valence Bond Theory explains the formation of the covalent bond. Well, there are a few important points which you need to take a note of in this Valence Bond Theory, which I'll be explaining one by one right here. The first important point, a covalent bond is actually formed by the overlap of atomic orbitals of the bonding atoms. What does that mean? Understand. For example, let's assume this is atom A. This is the nucleus of the atom A. This is, for example, atom B. and this is the nucleus of the atom B, right? For the formation of the covalent bond, as per valence bond theory, these atoms should approach each other. Why they should approach each other? Because as per your valence bond theory, covalent bond is only formed by the overlap of atomic orbitals of different bonding atoms, correct? See, let's assume a covalent bond has to be formed between atom A and atom B. So what has to happen right here? These atoms must approach each other. Why they have to approach each other? Then only their atomic orbitals can penetrate into each other, and that penetration of atomic orbitals into each other is what we call as overlap, right? So for the covalent bond to get formed, the atomic orbitals, the atoms must approach each other so that the atomic orbitals will penetrate into each other, and that penetration of atomic orbitals of two atoms into each other is something which I call as covalent bond actually, okay? I mean, that's something which I call as overlapping. And due to that overlapping, a covalent bond gets formed, which I'll be telling you one by one in detail, yeah? This was point number one. Point number two, which I already told you, in order to show the overlap, the bonding atoms must come close such that their atomic orbitals can overlap, such that these atomic orbitals can penetrate into each other, right? This was point number second, which I want you guys to take a note of, correct? So people, in short, for the covalent bond to get formed, the atoms must approach each other, right? What will happen due to that? Then only the atomic orbitals of two atoms will come closer. Then only the penetration of atomic orbitals into each other will happen, and that penetration of atomic orbitals into each other is what we call as overlap, and that overlap leads to the formation of something called as covalent bond, correct? All right. See guys, one more important point right here, which is on your screen. When the atoms approach each other, two types of forces act. What are those forces? One is called as a repulsive force, one is called as attractive force, right? What do we mean by this statement right here? Okay, so let me make you understand this statement as well. See guys, understand properly what I'm going to say. Let's assume this is the atom A, this is the nucleus of the atom A. This is the nucleus of the atom A, which I'm representing by Na, correct? Let's say this is the electron which belongs to this atom A right here, which I'm representing by Ea, okay? Now people, I have got one more atom right here, which I'm calling as atom B. Let's assume this is the nucleus of the atom B, which I'm representing by Nb. Yes, and this is the electron which belongs to atom B. This is something which I call as Eb. Yes. Now the first thing, when these atoms will be at infinite distance apart, there will be no force of attraction between these atoms. Yes, because you all must be knowing. Well, someone is saying screen is blur. Is my screen blur? People, is it not properly visible? Is it not properly visible? Just let me know once. Is the screen visible properly to everyone? Just a second, let me check it out. Yeah, it's completely visible to me. I think there's a problem from your side. Or my side, it's all okay. All right, see guys. First thing, this is the atom A, this is the atom B, correct? Now, as you all must be knowing, force of attraction is simply inversely proportional to the distance between the atoms, correct? More the distance between the atoms, less is going to be the force of attraction. Less the distance between the atoms, more is going to be the force of attraction, correct? Now people, let's assume these atoms right now, they are at infinite distance apart. If the atoms will be at infinite distance apart, I'll say force of attraction between these atoms will be approaching towards zero, correct? Now people, when these atoms will approach each other, when these atoms will come closer to each other, two forces arise. See guys, understand. First thing, this electron of atom B, this Eb, I mean electron of atom B, it will be attracted by the nucleus of atom A. This is one kind of attractive force between nucleus of atom A and electron of atom B. At the same time, this electron of atom A will be attracted by the nucleus of atom B. Yes. So the attractive force which arises between these two atoms is between nucleus of B, electron of A, and nucleus of A, electron of B. Yes. And at the same time, one more force will come into play. That's called as repulsor force. Repulsor force is going to be between these two nuclei. right? Repulsor force will be between these two nuclei, and at the same time, repulsive force will be between these two electrons. So when these atoms approach each other, two kinds of force will arise right here. One is attractive force, one is repulsive force, right? Now, people, one more important point. Attractive forces, these are long-range forces, whereas repulsive forces, these are short-range forces. See, guys, understand one important thing. Let's say this is the atom A right here. This is the atom B right here, correct? And I'm assuming right now these are at infinite distance apart. If these are at infinite distance apart, force of attraction between them is going to be zero, as you all must be knowing. Yeah? Now, when these atoms will approach each other, what is happening to the distance between them? I'll say when the atoms will approach each other, the distance between the atoms will decrease, force of attraction will increase. Yeah? So as the atoms keeps on coming closer, distance keeps on decreasing, force of attraction keeps on increasing. There will be a stage when the atoms will be at maximum closest distance, right? And when the atoms are at maximum closest distance, I'll say force of attraction between these two atoms will be maximum. Yes? So can I say when the atoms were far? At that time, attractive force was operating between the atoms? Now, this is the scenario when the atoms are at maximum closest distance, force of attraction right here is maximum. Now, people, after this point, if I want these atoms to come a little more closer, now repulsive force will start between the atoms, yeah? So I can say your attractive forces, they are long-range forces, whereas your repulsive forces, these are short-range forces, yeah? And due to the attractive forces, the energy of the system decreases. Whenever there is attraction between the atoms, remember, energy is released. Whenever there is attraction between the atoms, energy is released, and potential energy of the system is decreased. And decrease in the potential energy leads to the stability. I want you guys to remember this as well, okay? So what you guys are supposed to remember right here, whenever atoms approach each other, distance between the atoms decreases, force of attraction increases, energy is released, right? Potential energy of the system decreases, stability increases. As you all must have studied in your thermodynamics, I have taught you that, right? Stability and energy, these are inversely proportional to each other. Yeah? So remember, your attractive forces, they decrease the energy of the system, whereas your repulsive forces, they increase the energy of the system. This was one more important point, right? So when the atoms approach each other, two types of force exist, attractive, repulsive. Due to attractive forces, the energy of the system decreases, and due to the repulsive forces, energy of the system increases, right? Now people, there is one important curve between the energy and internuclear distance, okay? There is one important curve between the energy and internuclear distance. What is that curve all about? Understand properly what it's going to be. See, guys, along y-axis, I'm plotting energy. Along x-axis, I'm plotting internuclear distance, yeah? See, first of all, I have got two bonding atoms. This is atom A, atom B, and they are going to form a bond right over here. Yes? So as per your valence bond theory is concerned, in order to form a covalent bond, the atoms must approach each other. Yeah? Right here, I'm assuming the atoms are at infinite distance apart. We know force is inversely proportional to distance, right? And when the atoms are at infinite distance apart, the force of attraction between the atoms approaches to zero. Yes? So right now the atoms are at infinite distance apart, force of attraction between them is zero, correct? Now people, when the atoms will start approaching, what is going to happen to the distance? Distance between the atoms will decrease. What will happen to the force of attraction? Force of attraction will increase. Increase in the force of attraction leads to decrease in the potential energy of the system. Yes? So people, when the atoms were at infinite distance, force of attraction was zero. Yes? So potential energy of the system was zero. Now the atoms are coming closer. See, guys, this point represents the distance between the two atoms is zero, right? As I move along positive x-axis right here, the distance between the atoms is increasing. So over here somewhere, the distance between these atoms will be infinite, force of attraction will be zero. Now the atoms are coming closer. If the atoms are coming closer, what is happening to the distance between them? Distance between the atoms is decreasing, force of attraction increasing, and the potential energy of the system will be decreasing. Yes? So people, the curve between energy and internuclear distance, it's going to follow like this. Understand? As the atoms are coming closer, potential energy of the system is decreasing. Yeah? Like this. Potential energy of the system is decreasing. Correct? And let me make it further more clear so that, just a second, guys. Just a second. See, it's going to be like this, right? As the atoms are coming closer, force of attraction increases and potential energy of the system decreases, right? This is the minimum value of potential energy. This is the minimum value of potential energy of the system, of the molecule, which is going to get formed, right? Now people understand. Now people understand. Can I say, when the atoms were at infinite distance, force of attraction was 0. Now the atoms are coming closer. Atoms are coming closer, force of attraction increases, energy of the system decreases, right? So this is the minimum energy of the system. And when the energy of the system will be minimum, I'll say the atoms will be at maximum closest distance, right? So at this point where the potential energy of the system will be minimum, at this point the atoms will be at maximum closest distance, right? And this maximum closest distance is what I call as bond length, which I represent by R naught, okay? So at maximum closest distance, this maximum closest distance at which the potential energy of the system is minimum, stability is maximum, this distance between the atoms is what I call as bond length, right? Now people, as I told you earlier, if I want these atoms to come a little more closer, what is going to happen? Repulsor force will start, and repulsor forces always leads to increase in the energy of the system. Now the energy of the system will increase like this, yeah? It will increase like this. So this is one important curve which I want you guys to take a note of right here, okay? Now people, there is one important thing to notice right here. Understand. See, this is potential energy versus internuclear distance R curve, correct? So at this point, if I'll draw the tangent, or let me tell you like this, if I ask you what is going to be the slope of this curve at this point. First of all, at this point, the potential energy of the system is minimum, yes, and the slope of energy versus internuclear distance curve right here is 0. The slope is 0 right here, yes. Now this is the concept which I'll be using in one particular type of question. And what is that question going to be? Understand. See guys, the variation of potential energy with internuclear distance R between atom A and B is given. This is a relation between potential energy and internuclear distance R. Calculate the bond length in angstroms. I'm supposed to calculate the bond length in angstroms. How will I be approaching this sort of equation? As I told you right here, see, this was the curve like this, correct? This was the potential energy versus distance curve versus internuclear distance curve. At this point, the potential energy of the system was minimum, and at this point, the atoms were at maximum closest distance, and that maximum closest distance I used to call as bond length, right? I used to call as bond length, correct? And at this point, the slope of potential energy versus R curve, at this point, at point A, for example, the potential energy versus R curve, the slope of potential energy versus R curve is 0, correct? So what I'm given with the relation between U and R, and I'm supposed to calculate the bond length, right? The concept which I'll be using right here, see, at the bond length, I'll say the slope of the curve, which is basically du upon dr, slope of potential energy versus curve versus R curve, it's going to be du by dr. It's going to be actually 0, yeah, at this point. Yes, because the tangent is parallel to x-axis, right? The tangent is parallel to r-axis, right? So the slope is going to be 0. Now people, I'm going to differentiate this function with respect to r, correct? I can write it like this as well, 6r raised to power minus 2, 6r raised to power minus 2 plus 3r plus 2, right, is basically equal to u with respect to r, correct? Now, I'm going to differentiate this u with respect to r. What is it going to be? Du divided by dr, understand. It's simply going to be, take this minus 2 in the front, it's going to be minus 12 r raised to power minus 3, yes? Differentiation of x raised to power n, nx n minus 1, correct? Plus 3r differentiation is going to be 3 is equal to 0, correct? Now people, take this r on that side, it's going to be at the end 12 divided by r cube is equal to 3, or I can say something like this, I can say 3r cube is equal to 12, or I can say r cube is going to be 4, or I'll say r is going to be 4 raised to power 1 divided by 3 angstroms. So this is basically the maximum closest distance between the atoms A and B, which I'll be calling as the bond length, which I was supposed to calculate, right? So let me know in the chat box if the concept is clear to you. Let me know in the chat box if the concept is clear to you. Yeah? Yes, Karthik, exactly. Let me know in the chat box if the concept is clear to you. Correct? Good evening, Jagdish. Good evening. Welcome to the session. Okay. So people, I hope this is clear to everyone till now. Okay. Now let's move on and let's talk about the actual stuff that's called as overlapping, right? As I told you earlier, as per your valence bond theory is concerned, a covalent bond is formed by the overlapping of atomic orbitals, right? Yes. Now, what is that overlapping? Overlapping is nothing. It is the penetration of atomic orbitals of two atoms into each other. Yeah? I'm going to talk about that overlapping right here in detail. Okay? See guys, as I told you, overlapping is nothing. It is the penetration of atomic orbitals into each other. That's something which I call as overlapping. Now, there are different types of overlapping and rules of overlapping as well. Correct? Now, the first rule, which you would have studied earlier as well, I'm sure about that. More the extent of overlapping between the atomic orbitals, I'll say more is going to be the strength of the covalent bond, right? So the first important point which I want you guys to take a note of, greater the extent of overlapping, more is going to be the strength of the bond formed, right? Because something which I'll be telling you a few minutes afterwards, which you'll be getting to know that due to the overlapping, covalent bond is formed, correct? So remember that thing right now. Due to the overlapping of atomic orbitals, covalent bond is formed. And the strength of the covalent bond, which is getting formed due to the overlapping, depends on the extent of overlapping. More the extent of overlapping between the atomic orbitals, more will be the strength of the bond, which is something you need to take a note of, yeah? Now, point number 2. After the overlapping is done, once the overlapping between the atomic orbitals is done, once the penetration of atomic orbitals into each other is done, what happens? After that, electron density arranges itself in such a way that it comes under the influence of both the nuclei, okay? What does that mean? You'll get the slight idea in some time, okay? But before that, before making you understand the second statement right here, I need to talk about the types of overlapping first of all. Okay, once you get familiar with the types of overlapping, then only both these statements will be clear to you, right? Now guys, see, the types of overlapping. We have got two types of overlapping basically. One is called as axial overlapping and one is called as parallel or sideways overlapping, right? One is called as axial overlapping, one is called as parallel overlapping or sideways overlapping. The first point, which you should take a note of right here, due to the axial overlapping, always sigma bond is formed. And due to the parallel overlapping, always pi bond is formed. Now the point is, what is the sigma bond? What is this pi bond? What is axial overlapping? What is this parallel overlapping? Let's get to know this axial overlapping and parallel overlapping right here in detail. See guys, the first type of overlap, which is what I call as axial overlap. See, as per its definition is concerned, when the two atomic orbitals overlap along their axis, okay, when the two atomic orbitals of two atoms, okay, I've got two atoms, they are approaching towards each other. Why they are approaching towards each other? Because they want to form a covalent bond, right? And for the formation of covalent bond, what they have to do? Their atomic orbitals must overlap, right? Now this overlapping is of two types. First one is called as axial overlapping. When the atomic orbitals overlap along their axis, when these atomic orbitals overlap along their axis, like this guys, see. Let's say this is the s orbital of one atom. Let's say this is the s orbital of one more atom, right? Now these orbitals are approaching each other because they want to form a covalent bond, right? See, this is, for example, the axis which I'm talking about. This is the axis of this one as well. When they will be overlapping, when the two atomic orbitals overlap along their axis, right? This type of overlapping is what I call as axial overlapping. And due to the axial overlapping, always sigma bond is formed. Yes, let's talk about this overlapping a bit more in detail. For that, you need to know the axial overlapping, right? You need to know the axial overlapping, which is actually of three types. The first one is what we call as SS overlap. Remember, due to the SS overlap, due to the axial SS overlap, always a covalent bond is formed. Which kind of covalent bond? It is going to be a sigma bond, right? Because right here I'm talking about the axial overlapping, correct? Now guys, see what happens. What happens in SS overlapping? See, understand properly. Let's say this is the s orbital of one atom. This is the nucleus of it. Yeah, this is the s orbital of one more atom. This is the nucleus of it. Yeah, this is atom A and this is atom B. Well, let's say this is the axis I'm talking about. This is the internuclear axis right here, correct? Now people, what these atomic orbitals are going to do, they are going to come closer so that their atomic orbitals penetrate into each other, correct? And these atomic orbitals are overlapping along their axis, correct? They are overlapping along their axis. So it's first of all, which case? It's the head-on overlap. Head-on overlap means that it is the axial overlap, right? So what is going to happen? The atomic orbitals are going to penetrate into each other like this. Yes, this is the nucleus of atom A, this is the nucleus of atom B, and this is the common electron cloud which is between these two, correct? This is something which I call as overlap. If I ask you, is it the head-on overlap? Yes, it's a head-on overlap, and head-on overlap is what I call as axial overlap, and axial overlap always leads to the formation of sigma bond, right? So right here, sigma bond got formed, correct? Now people understand. How do I represent it finally? As I told you, as per the second statement, which I didn't define few minutes back, right? See, I told you the electron density, this electron density, which I'm talking here right now, okay? This common electron density, it's going to arrange itself in such a way that it's under the influence of both these nuclei, right? So it's going to be, the final structure is going to be like this. See, see guys, the final structure is going to be like this. Just a second. This is the nucleus of atom A. This is the nucleus of atom B, right? And the electron density, the common electron density, has arranged itself in such a way that it's under the influence of this nucleus as well as this nucleus, right? So which kind of bond got formed right here? This is basically the sigma bond. So this is first kind of overlapping which you need to remember, yeah? Let me know in the chat box if it's clear till here so that I can move on and talk about one more axial overlapping. Let me know in the chat box if it's clear till here. Let me know in the chat box if it's clear till here, yeah? Perfect. Now guys, there is one more type of axial overlap. Or before that, this is something which I told you, this s orbital, they are overlapping, head-on overlap, right? It leads to the formation of sigma bond like this, yeah? This is the final structure. This is the final structure. Now, talking about one more overlap, it's going to be sp axial overlap. sp axial overlap, understand. Let's assume this is the s orbital of one atom. This is the nucleus of it. This is the p orbital of one more atom, right? And this is the nucleus of it over here, correct? This is the nucleus of it, for example. Yeah, or let me change the color of it so that it will be visible. This is the nucleus of it, correct? Now people, they are going to show what? They are going to show head-on overlap, right? Head-on overlap is what I call as axial overlap, and axial overlap always leads to the formation of what? It leads to the formation of sigma bond. So first of all, when they will penetrate into each other, what is going to happen? This is your s orbital of atom A, for example. This is atom A, this is atom B, yeah? Now, your p orbital of atom B would have penetrated like this, correct? And this is the nucleus right here of atom B, correct? And people, this is something which I call as overlap. Is this the head-on overlap? Yes, this is the head-on overlap, right? And head-on overlap leads to the formation of what? It leads to the formation of sigma bond. So sigma bond got formed right here again. Now people, one more important thing, understand. Now this electron density is going to arrange itself in such a way that it is under the influence of both these nuclei, right? So what is going to be the final structure right here? What is going to be the final structure right here? Simple guys, final structure is going to be like this. See guys, understand. This is the nucleus of one atom, the atom A, and over here, this is the nucleus of atom B. Now the electron density which is over here, it has arranged itself in such a way that it's under the influence of these both nuclei, right? And right here, what got formed? Just a second. Right here, what got formed? A sigma bond got formed because it is the axial overlap, right? This is again the sigma bond. I hope this is clear to everyone. Let me know in the chat box. Let me know in the chat box. Let me know in the chat box. Adil, just wait for it. You'll get your answer in a while. Okay, that's something which I'll be teaching next. Okay, this was your sp axial overlap, right? Which leads to the formation of sigma bond again. Now people, one more thing. That is going to be your pp overlap. But before talking about pp overlap, this is something which I've shown you. This is s orbital of one atom, p orbital of one more atom. They have directly head-on overlapped and it leads to the formation of what? Sigma bond. This is sp axial overlap, yeah? Now, talking about the pp axial overlap. See guys, this is the last type of axial overlap which leads to the formation of sigma bond right here. Okay, see, let's assume this is the p orbital of one atom. This is the p orbital of one atom. Yes, and it's going to show the axial overlap with the p orbital of another atom. This is, for example, p orbital of one more atom, correct? And they are going to do the overlap along the axis. They are going to do the overlap along the axis, right? So people, they'll just this lobe of p orbital of atom A and this lobe of p orbital of atom B, they are going to head on, they are going to overlap head on, okay? And what they will lead to the formation of, see, this is the nucleus of this p orbital and this is one lobe. This is, for example, it's one more lobe. Similarly, this is the nucleus of another p orbital and this is its one lobe, it's one more lobe, yeah? So right here, this is something which I call as overlap. And which kind of overlap this is? This is PP overlap. Is this the axial overlap? Yes, they are overlapping along the axis, right? So it leads to the formation of what? It leads to the formation of sigma bond right here. So finally, if I need to represent the structure, it's going to be like this. See guys, it's going to be like this. Understand properly. It's going to be like this, yeah? So this is right here. Let me show it to you. This is the nucleus of one p orbital. This is the nucleus of another p orbital. And electron density has arranged itself in such a way that it's under the influence of both the nuclei right here. Yeah? So this is my sigma bond which got formed by PP axial overlap right here. So you can let me know in the chat box if it's clear to everyone. You can let me know in the chat box if it's clear to everyone. These were three types of overlaps, right? Which leads to the formation of what? Sigma bonds, yeah? Perfect. Now talking about something called as parallel overlap, right? Now see guys, what happens in parallel overlap. See, this was your PP axial overlap. Now let's talk about the parallel or sideways overlap, right? The overlapping orbitals have axes parallel to each other. When the atomic orbitals will overlap in such a way that their axes are parallel to each other, it always leads to the formation of what? It always leads to the formation of pi bond. Right here, let me give you the example. See, let's say this is the p orbital of one atom. Let's say this is the p orbital of one atom and this is the nucleus of it. Yes, and let's assume this is the p orbital of one more atom and let's assume this is the nucleus of it. Yeah, like this. Just a second, this is the nucleus of it, this is the nucleus of it. Now people, this is its axis. This is the axis of this p orbital. Let's assume this is the p orbital of atom A. Let's assume this is the p orbital of atom B. Now now right here I can say their axes are parallel to each other, and whenever there is parallel overlapping, it always leads to the formation of pi bond. So first of all, they are going to approach like this with their axes parallel, So what is going to happen? First of all, what happens? These lobes bend towards each other. In order to show the parallel overlapping, these lobes bend towards each other. Let's say this is the nucleus of this p orbital. Its lobe has got bent like this. Similarly, this lobe also has got bent like this. Its lobes bend towards each other first, okay? Now talking about this p orbital, this is its nucleus, for example, yeah? So its lobe also has bent in this direction and this lobe has also bent in this direction. So what happened right here? Can I say this is something which I call as overlap, right? This is the overlap, yes. And which kind of overlap this is? This type of overlap is what I call as parallel overlap, right? And parallel overlap always leads to the formation of a bond, which is what we call as pi bond. I'm sure this is clear to everyone, yeah? Now people, one more interesting thing. See guys, the electron density right here in this overlapping, the electron density lies above the plane. This is the electron density which I'm talking about, and below the plane, yeah? Electron density lies above the plane and below the plane. So right here, a plane will exist right here. A plane will exist right here like this. Let me change the color of it. A plane will exist right here, okay? This is the plane at which the electron density is going to be 0. And the plane at which the electron density is going to be 0, that's what we call as a nodal plane. That's what I call as nodal plane. Or let me represent it differently for you. See guys, so this is the electron density which is lying above the plane, right? This is the electron density which is lying above the plane. So first of all, this was one nucleus, this was another nucleus. This is electron density which lies below the plane like this, yeah? And right here, what you'll observe, there is a plane like this where the electron density is going to be 0, and this plane is what I call as nodal plane, which I've already written over here, okay? And since this was the overlapping in such a way that their axes were parallel to each other, okay? And whenever there is parallel overlapping, whenever there is sideways overlapping, it always leads to the formation of what? It always leads to the formation of pi bond. So let me know in the chat box if it's clear to everyone. Simi, this is the English channel. I'm not supposed to talk in Hindi. I'm really sorry for it. Well, we have got few more Hindi channels as well, right? You can go to Vedantu Hindi NEET channels or JE channels. There people talk in Hindi. Yeah. This channel is particularly for the ones who cannot understand Hindi. Yes, Sunil, exactly. So I'm sure this is something which is clear to everyone. Yeah. Now we will understand few more things. So till now you got to know how your sigma bond and how your pi bonds are formed. Pi bonds and sigma bonds, they are basically formed by the overlapping, be it axial or parallel, right? And these pi bonds and sigma bonds, these are basically your covalent bonds, correct? Now people, this is something which I've shown you right here, correct? This was p orbital of one atom, p orbital of another atom. They overlapped, right? And this was something which I called as parallel overlapping, right? Because their axes were parallel to each other during overlapping, yeah? And the electron density was above the plane and below the plane. So this plane in between is something where the electron density is zero, which is what I call as nodal plane, yeah? Perfect. Now there is something called as strength of sigma and pi bond, okay? Which bond is comparatively strong? Which bond is comparatively strong? Sigma bond or pi bond? Let's get to know about that as well. See guys, if I talk about SS overlapping always leads to the formation of sigma bond, yeah? And the final structure, which was like this, I hope you remember. This is, for example, SS overlapping, right? And this is the sigma bond which has got formed due to SS overlapping. Yes, this was the overlapping final structure during SS overlap, right? This was the sigma bond. Similarly, what about the pi bond? What about the final structure? Final structure in case of pi bond used to be like this. This was the electron density which was above the plane, correct? This was the nucleus, and this was the electron density which was below the plane, right? Like this. Yeah, and over here what used to happen? Over here I used to have a nodal plane like this, correct? I used to have a nodal plane like this, correct? Now people, right here which bond is this? This is the pi bond which we have discussed a few minutes back, like how it's formed, yeah? Now I need to compare the strength of these sigma bonds and pi bonds. Which bond is comparatively stronger? See guys, it's a very simple concept. There are two factors which can decide the strength of the bond. The first factor, which I told you already, that's extent of overlapping. That's extent of overlapping. Remember, extent of overlap in axial, extent of overlap in axial is always greater than extent of overlap in parallel. Extent of overlap in axial is always greater than extent of overlap in parallel. This is the axial overlap, this is the parallel overlap. Extent of overlap in axial, which leads to the formation of sigma bond, is always greater than the extent of overlap in parallel overlap, right? So I can simply say, as per the extent of overlap concept, your sigma bond is going to be stronger than that of your pi bond. This is reason number one, which gives me the idea of why your sigma bonds are comparatively stronger than that of pi bonds, yeah? Now people, one more thing. There is one more factor, that is energy factor, right? As I told you in the beginning, repulsions always increases the energy of the system, due to which stability is decreased. Yes? Yeah? Repulsions always increases the energy of the system, due to which stability gets decreased. This is something which I told you in the beginning. Right here, in case of sigma bond, can I say between the nucleus, there is the electron density which is shielding the repulsions between two nucleuses, right? This electron density is basically shielding the repulsions between the two nucleuses. Right here, this is the nucleus, right here, this is the nucleus, and right here, there is a nodal plane. There is no electron lying in this plane. Can I say this nucleus and this nucleus, between them, there are no electron density. There is no electron density which could have shielded the repulsions, right? So you can easily tell me wherein the repulsions are going to be more. Can I say repulsions right here is going to be more? Wherever the repulsions are more, I'll say energy of the system is more, and wherever energy of the system is more, stability is less, right? So I can say your pi bonds, these are comparatively less stable than that of sigma bonds, or I can say strength of pi bond is less than that of strength of the sigma bond. I'm sure this is clear to everyone, yeah? Correct? Correct. Let me know in the chat box if it is clear. right? So in short, you are going to remember one thing: sigma bonds are stronger than that of pi bonds. That's it, right? So you can remember either of the reasons, or the first reason was the extent of overlap, the second was the energy factor. Yeah. Ayat, you can do one thing, you can just drag the video a little back, it'll be automatically a replay. Karthik, just wait for it. I'm telling that in some time. Just wait for that. Yes, yes, Lakshmana Rao, you can go ahead with the doubt. All right, guys, perfect. So your sigma bonds are stronger than that of pi bonds because of the extent of overlap in axial, which is greater than that of sideway overlap. And this was the energy factor, which I told you. Yes, in case of sigma bond, the electron density is between the nuclei, okay, which comparatively reduces the repulsions, whereas over here, there is no electron density in between, which reduces the repulsions, correct? Now, guys, one more important thing, which is something which you need to remember. That is, for the same energy shell, overlapping axial follows this order, right? Your axial overlapping, it follows this order. Remember, extent of overlap. Let me give the example directly. For the same energy shell, remember, 2p overlap is maximum, followed by 2s2p overlap, followed by what? Followed by 2s overlap, right? For the same energy shell, right? I'm talking about the same energy shell, right? That energy shell is 2. That energy state is 2. For the same energy state, remember 2p overlap. In case of 2p overlap, the extent of overlapping is maximum, followed by 2s2p, followed by 4 by 2s, yeah? Similarly, you can say 3s overlap. The extent of overlap in 3s will be less than that of extent of overlap in 3s3p, which will be less than that of extent of overlap in 3p, correct? This is something which you need to take a note of, correct? So you can decide right now if a bond, for example, I'm talking about axial overlapping. Axial overlapping leads to the formation of sigma bond, right? So this is, for example, axial overlapping, this is axial overlapping, this is axial overlapping, right? So right here, sigma bond would have got formed, right here, sigma bond would have got formed, right here, sigma bond would have got formed. So wherever, in these three cases, where the strength of the sigma bond would have been maximum, there only the strength of the sigma bond will be maximum, where the extent of overlapping is going to be more. And the extent of overlapping will be more in 2p, followed by 2s2p, followed by 2s2s, yeah? That's one important point which I want you guys to take a note of, yeah? Now, people, one more thing. If orbitals of different energy shells, if the orbitals are of different energy shells, then lower energy orbitals produce more effective overlap, okay? For example, in this case, see, 1s overlap is definitely going to be more than that of 1s overlap, right? If the orbitals are of different shells, the lower energy orbitals, they are going to produce more effective overlap. Or I would say the extent of overlap in 1s is definitely going to be the extent of overlap in 1s, right? So the bond which is getting formed right here will be comparatively stronger than that of bond which will be getting formed right here in case of 1s, yeah? Right? Venkata, it is normal Wassim, but WASSIM, BHAT, yeah? Okay, moving ahead. Okay, or this is one more example. This is something which I told you. Say 2p, this is 2p, 3p. So lower energy is going to show more extent overlap compared to the higher energy, right? This is 2p overlap, this is 2p, 3p overlap, right? Correct? Now, guys, one more important thing. Now, let me show you exactly, as per valence bond theory, how molecules are getting formed. Okay, let me show you exactly how molecules are getting formed. For example, I'm going to show you the formation of N2 molecule by using valence bond theory. Or leave the N2 molecule aside. Let me show you, first of all, how F2 molecule is formed. How F2 molecule is formed by using what? By using the valence bond theory. Understand properly, okay? Because the same concept I'm going to use in the next session of bonding, which is going to be the hybridization. See, guys, I've got one fluorine atom. This is one more fluorine atom. Yes. What is the outermost configuration of the fluorine atom? It's 2p5. What about the outermost configuration of the fluorine? It's 2p5. Yeah. Now, people, 2p has got 3 orbitals, as you all must be knowing. And you have got how many electrons? 1, 2, 3, 4, and 5. Yes. Similarly, right here we have got 3 orbitals, right? 1, 2, 3, 4, 5. Yes, 5 electrons in this 2p. Correct? So right here, this is unpaired orbital. Right here, this is unpaired orbital. Let's call this as px. Let's call this as 2py. Let's call this as 2pz. Yes. Similarly, let's call this as 2px. Let's call this as 2py. Let's call this as 2pz. Right? So people, First of all, for the formation of the sigma bond, the atoms must approach each other as per your valence bond theory. So these atoms will be approaching each other, correct? So first, let me draw the structure of this. Let me draw the outermost structure of this fluorine right here. This is its 1p orbital, your, for example, py. This is its one more p orbital, it's px, for example, and this is its one more p, which is pz, right? Px contains 1 electron, py contains 2 electrons, and pz contains 2 electrons, right? This is the outermost structure of your fluorine. Similarly, talking about one more fluorine, it has got the same kind of a structure like this. This is the orbital diagram of it. This is, for example, py of 1, this is px, and this is, for example, pz. Your px contains 1 electron, py contains 2 electrons, and pz right here contains 2 electrons. Now, what is going to happen? In order to form the covalent bond, what is going to happen right here? They must approach each other. Yes, and when they'll approach, can I say this slope and this slope, they are going to penetrate into each other, right? It's going to be a head-on collision, it's going to be a head-on overlap, and head-on overlap leads to the formation of a sigma bond. So right here, there will be the formation of sigma bond, correct? So this is, for example, px of one fluorine atom, this is px of one more fluorine atom, and this is the overlap I'm talking about. Rest all the orbitals will remain same. This is py of 1, this is pz of 1. Yeah, similarly over here, this is px of 1, py of 1. Right? So this is what? This is the axial overlap, which leads to the formation of sigma bond. And this electron density is going to arrange itself in such a way that it's under the influence of both these nucleus number 1 and nucleus number 2. So this is your F2 molecule, which looks like this as per your valence bond theory, correct? Similarly, if I talk about the formation of O2 molecule, okay? This was the formation of F2 molecule. Let me give you the formation of O2 molecule. Let's see how O2 molecule is formed. Yes. Now guys, this is, for example, one oxygen atom. This is one more oxygen atom, right? What is the outermost configuration of oxygen? It is 2p4, right? What about the outermost configuration of this oxygen? It's 2p4. Yes. So the configuration is going to be somewhat like this. Your 2p contains 3 orbitals, 1 electron, second one, third, and this is the fourth one. Yes. What about this oxygen? It has got, again, 3 orbitals in 2p subshell, and these are your 4 electrons like this. Yeah. Let's say this is your 2px. Let's say this is your 2py. Let's say this is your 2pz. Similarly, let's keep this as 2px. Let's keep this as 2py. Let's keep this as 2pz. Okay. So first, let me draw it perfectly. This is the nucleus. This is the nucleus of this oxygen. And this is, for example, 2px. This is 2px orbital of this oxygen, which contains 1 electron. Similarly, your 2py, it contains 1 more electron. Correct? And 2pz, like this, it contains how many? 2pz contains 2 electrons, like this. Yeah. This is the outermost diagram of this oxygen. Similarly, I've got one more oxygen like this. It's going to have same. Your px contains 1 electron, py contains 1 electron, pz contains 2 electrons. So let's say this is the nucleus of one more oxygen, and when it would have approached something like this. This is your 2px of another oxygen. Okay, this is your 2py of another oxygen, which contains 1 electron, and this is 2pz of the oxygen, which contains 2 electrons, correct? So can I say right here what happened? What happened right here? Axial overlapping took place, and axial overlapping leads to the formation of sigma bond. So first of all, sigma bond got formed. Yes. Now people, at the same time, if you talk about this one, see, if I consider this axis, and this axis right here, okay, can I say these lobes, this lobe and this lobe, they'll bend towards each other. Similarly, this lobe and this lobe, they would have bent towards each other, and they would have formed what? They would have formed the pi bond right here, like this. Yeah. So right here, 1 sigma and 1 pi got formed. Right here, 1 sigma and 1 pi got formed in O2 molecule. I'm sure this is clear to everyone. Yeah. Well, Lakshmana, I have taken almost all physical chemistry. The lectures are there in playlist. You can check the playlist. I have taken all these chapters of physical chemistry. There are only 2 chapters left in physical chemistry which I have not taught. That is solution and atomic structure. That I'll be doing soon. Guys, don't get confused. This is a 1 pi bond. These are not 2 pi bonds. This is a 1 pi bond. This is how we represent it, okay? This is a 1 pi bond. Electron density above the plane, electron density below the plane. And in the plane as well, right? That is the sigma. Okay? Now, let me show you the formation of N2 molecule as well. Okay, with that, we'll end today's discussion. Let me show you the formation of N2 molecule as well. See guys, your formation of N2 molecule as per what? As per your valence bond theory, right? As per V.B.T. Now people see, let's say this is your one nitrogen atom, this is one more nitrogen atom. If I ask you what is the configuration of nitrogen atom, it's 2p3. Outermost configuration I'm talking about. What about this one? It's again 2p3. Yeah. So your 2p, as you all must be knowing, it contains your 3 orbitals. Every orbital has got one electron, right? Similarly, your 2p right here, these are 3 orbitals of your 2p. Every orbital contains one electron. Yeah. Let's call this as 2px. Let's call this as 2py. Let's call this as 2pz. Similarly, let's call this one as 2px. Let's call this one as 2py. Let's call this one as 2pz. Okay. So if these two atoms have to form a covalent bond, they should definitely approach each other, right? They should approach each other. Now, how will they be approaching each other? Understand. Just a second, guys. See. First of all, let me make the diagram. So this is one of the p orbital of this nitrogen, which contains one electron. This is one more p orbital of the same nitrogen, which contains one more electron. And this is one more p orbital of same nitrogen, which contains one more electron. And another nitrogen would have come from this side. It would have done the overlap right here. This is the nucleus, for example. Okay, this is one lobe. This is one more lobe, right? And this p orbital of another nitrogen, it also contained one electron, right? And they showed the axial overlap right here, which leads to the formation of sigma bond. So sigma bond got formed. Yes. Now there'll be one more p, which is py of this nitrogen, which contains one electron. And similarly, there'll be one more p, that is pz, which contains one more electron. Yeah. Now what is going to happen? Understand. Can I say this p orbital and this p orbital, they have got x's in parallel. So what they would have formed, they would have done the sideways overlapping, and they would have led to the formation of what? Your pi bond. Correct? Now people, at the same time, understand. This is, or let me change the color of the pen so that it will be completely visible to you. See guys, this is the axis of this p orbital, and this is the axis of this p orbital. Can I say these two axes are again parallel to each other? So can I say this one, and similarly this one and this one, they would have formed the one more pi bond. Yes. So till now you got to know, in case of your N2, this was your sigma bond which got formed. This was sigma, and this was one pi bond. This was one pi bond, and this one is another pi bond. So one sigma and two pi bonds were formed due to the formation of N2 molecule as per your valence bond theory. Okay. So let me know in the chat box if your actual valence bond theory is clear. Let me know in the chat box. Let me know in the chat box. Let me know in the chat box. Well, Aisha, you can type your questions after the session in the comment box. I'll be helping you out there. Okay. Yes, Karthik, exactly. Okay, perfect, guys. So this was all about your valence bond theory. I'm sure this is clear to everyone. So people, the schedule for tomorrow, which you should remember, at 7:30 tomorrow, I'm going to start one more chapter of organic chemistry, that is hydrocarbons. Okay. So tomorrow at 7:30, I'm going to start the hydrocarbon. Do not miss this at all. And this is something which is happening on this channel tomorrow, right? And tonight at 10:30 p.m. on Vedantu JE English channel, I'm going to do super 50 questions. I'm going to do super 50 questions from general organic chemistry. Okay, so you can watch this session too. It's happening tonight on Vedantu JE English. Okay. Yeah, so do not forget to attend these two sessions. These are going to be very, very important. Yes, Karthik, exactly. JE channel today. Well, Ayman, I'll see hydrocarbons. Let's see how many lectures it'll take. I'll give the schedule tomorrow, okay? Perfect, guys. So this was all about the valence bond theory, okay? So let me take a leave, but before taking a leave, let me give the brief introduction about the NEET 2021 crash course, which we are going to start on the actual Vedantu platform. Apart from the YouTube session, on the actual Vedantu platform, we are going to start the NEET 2021 crash course. Well, people, in this NEET 2021 crash course, what all benefits you guys are going to get? Well, the first thing, you're going to get trained by the teachers of your choice. Okay, it's completely your wish to select the teachers in your physics, chemistry, as well as biology. Okay, and before your NEET 2021 examination, we are going to cover your whole syllabus. We are going to train you personally, let me tell you frankly, okay? And people, at the same time, it's not only going to be the course completion sessions. There will be some sessions regarding the time management with the experts, okay, regarding the tips and tricks by means of which you can solve the questions in lesser time, okay? And people, no need to worry about the test series, no need to worry about the mock tests, everything is included. It's a complete package. It's a complete package to train you properly for the NEET 2021 examination. And people, trust me, I've seen people who are getting enrolled in this one in the last year. I've seen them shooting up their marks by 30, 40 to 50, like that, yeah? So do not forget to get enrolled in this one. It's going to be highly beneficial for you, okay? And the best feature is you can ask your doubt anytime to your master teachers, okay? It's going to be a two-way learning interactive platform wherein you can ask your doubts anytime to your master teachers, right? And people, how to get enrolled in this one? You just need to click on the Vedantu app. After clicking on the Vedantu app, just click on the NEET crash course. After clicking on the NEET crash course, you need to use the coupon code as WSNET. W stands for Wassim, S stands for Sir, okay? WSNET, it's my code. If you are using this code, then I'll be training you personally in your chemistry for the upcoming NEET 2021, okay? And after using this coupon code, first thing, I'll be training you personally. The second thing, you guys will be getting 30% off. And after 30% off, you guys are just getting this crash course for 7K, okay? That's not a big deal, I believe, right? So you can get enrolled in this crash course by another way as well. There's a link in the description box of the video. Click on that link, okay, and get enrolled. The next batch is starting on 19th of April. I'm surely going to see you all there, okay? Perfect, guys. So there is one more link in the description box. That's for the Telegram. Do click on the link, get added to the Telegram group and stay updated about the classes. And at the same time, for the ones who have not liked the video yet, please do like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions. Well, people, it was really nice meeting you in the today's session. I'll see you guys again at 10:30 on Vedantu JEE English, okay, in which I'll be doing super 50 questions from general organic chemistry, right? Well, sir, how to join NEET Eklavya? Well, you'll be getting the schedule soon to join the NEET Eklavya. Well, Lakshmana is saying, what about the crash course? I've given you the details. There's a link in the description box of the video, okay? Just click on the link. There will be, I mean, you just have to click on the link. That will be redirecting you always to the next page, okay? Right? And if you have further any more doubts about it, you can just let me know on my Instagram handle. That is Wassimbhat, WSSIMBHAT. I'll be briefing you about the NEET crash course, okay? So it was nice meeting you. I'll see you guys again tonight at 10:30. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.